Alright, so we're going to do trial number 2 right here. What I'm going to do is I'm going to only explain how I found like one of them because I used the same method to find all the rest of them, but explaining how I did them all kind of took a lot of time. So what I did was, so we have the steer tied up right here on our 12 by 9 shed. And then so I took our rope, which is 18 feet long, and I went 18 feet this way, 18 feet that way, and 18 feet this way. So that gave us 3/4 of a circle with a radius of 18 feet, which is where I got this. And then you have to account for the corners that the steer can go around. So it could go around this corner and it will have 6 feet of rope, giving us a quarter of a circle with the radius of 6 feet. And then it could also go this way and it could go down like this corner and it would have 9 feet of rope, giving us a quarter of a circle with a radius of 9 feet, which is where I got that and where I got that. And then I took those, I took these and I like actually multiplied them out and I got these numbers. And then I just added them together and I got 855.2985 feet squared. And then I did the same exact thing for this. Like right here I have my half circle and there's with a radius of 18, and right here I have my, like, if you combine these two, I have a half circle and with a radius of 1.5 feet. And then if you combine these two, I have a half circle with a radius of 13.5 feet. And then I got an answer of 798.9498 feet squared. And then if you flip over to the next page, I did the same thing here. Like I have a half circle with a radius of 18 feet. And then if you combine these two, I have a half circle with a radius of 12 feet squared, or yeah, just 12 feet. And then if you combine these two, I have a radius of 3 with a half circle. So, and then I got the answer of 749.2697 feet squared. Alrighty, so for this problem, we had to find the area of this triangle, and then we had to shear it in the later problems. So the first thing I did was I found the area. My favorite way to find it is to do the rectangle around it and then subtract the extras. So that's what I did, and I got 16 units squared. And then on the next page, I have the black rectangle equals, like how I found the area. So basically this rectangle and subtracting these extras. And then I have the black parallel lines is how I sheared. And then the green is my new triangle. So like right here you could see my black rectangle, and then I subtracted the extras. My green is my new triangle, and then here's the parallel lines I sheared off because the base is right here, so I drew a parallel line right there. And then right here is the same thing. I have the rectangle, and then I have the base right here, parallel line, and then I used my ruler and I did another parallel line, and then my green triangle. And then for figure 3, I have my base right here, and then my parallel line right there, and then my rectangle I used to find the area, like all these pieces I subtracted, and then my green is my new triangle. So for each one I sheared and I put my point right there, and then I got 16 units squared as my area, showing that the area does not change. And then same thing for this one, I put my point right here because it landed on my parallel line, and then I got 16 units squared, showing that the area does not change. And then the same thing for here, I put my parallel line on and I got my point right here, and then I also had an area of 16 units squared, showing that the area did not change.
For this problem, we're going to be looking how to get the formula for a trapezoid in 2 different ways. So the first formula that I have is 1/2 parenthesis a plus b parenthesis times h. And then how I got that is I split this into 2 triangles, and then we know that the area of a triangle is 1/2 times base times height. So for the first triangle, I have the base being a, and then for the second triangle, I have the base being b, and then I end up with these 2 formulas. And then when you combine them, you get our equation for our trapezoid. And then the second way is the formula that I have is a plus b times h divided by 2. And then how you do this is, so you cut this little sliver off, but you need to make sure that these 2 sides are congruent, and you're going to flip it over, and then you can see my little dotted line showing that when you flip it over, it makes like this triangle. And then like I said, we know that the formula for a triangle is 1/2 times base times height, or you could do the same thing, multiplying by 1/2 is divided by 2, which is where I got that. And then so now that we have this, our new base is b plus a, which is where that comes from, and then you multiply it by h because the height has not changed, and then you divide by 2. And then when I plugged the numbers into these formulas, I got 40 units squared and then 40 units squared.
So for this problem, we are dealing with a lake that has a perimeter of 110 miles. So we want the largest possible area. We don't care about the volume or anything, and we don't care what shape it is. So if you do a circle, you'll get the largest area, but the problem is we don't know r. So we had to do some algebra, and we did, I had 110 equals the formula of the circumference, did some algebra, and I got r equals 55 pi, and I plugged that into our area equation. And so I ended up with the area being 962.89 miles squared is the largest possible area we'll get. And then we also wanted to find the largest area, but it had to be a rectangle. And then so I chose to do a square because a square is always a rectangle. So I did 110 divided by 4 to figure out my side lengths would be. And so I got 27.5 for the side lengths. And then I just plugged that into the area formula for a square, which is like s squared. So 27.5 squared. And then I got 756.25 miles is the largest possible area we'll get if it has to be a rectangle. So the last problem we're going to be looking at is finding the, how do we get the area of a circle? Like, how do we come up with a formula? So I'm going to show you on paper first and then show you what I did on the computer. So we divide into infinite many sectors, so our circle then turns into a rectangle. And then we know that the rectangle's area is base times height. And then our height would be equal to r. And then our base would be equal to 1/2 times the circumference. So right here. And that's how we get pi r. And then so when we end up with r times pi r. And then when we combine that, we get pi r squared, which is the area of a circle. So if we were to take a look at this on my computer. Sorry. Okay. So we can expand this. So let's bring that out. And that gives you your circumference. It shows you your circumference is 2 pi r. And then if we were to rearrange this into like that shape, it's not really a rectangle right now because it's only cut into 6 parts, but if you were to expand it into 200 parts, you could see that the more you expand it, the more it changes to into a rectangle shaped figure. And so we could see that right here, our base is half of our circumference, and then r, which is our height, would be equal to the radius of the circle, which you can see when we go like this. So that's what our height is. It's equal to the radius. And that's how you come up with the equation of pi r squared.
Good morning, afternoon, evening, whatever time you're watching this, Dr. Miller. I just have 2 things I wanted to say really quick. So one is, I'm sorry that my voice sounds like a little weird during the test explanations. I fast forwarded all the clips by like 20% so that way they wouldn't take as much time up. And then the second is, I just wanted to say a big thank you for just being creative and caring and just coming up with all these different things for us to do during this time. I feel like you really are going out of your way to make sure we have a really good experience. So I just want to say thank you because I feel like you don't hear that enough. But keep up the good work, and I'll see you on Monday.